Okay, in question 6, I've got to find the points of inflection on the curve y equals e to the minus x squared. So, for a point of inflection, we need two things to be true. We need d2y by dx squared to be 0, but we also need some confirmation that it's changing from convex to concave, and for that we can try the third derivative. So, first thing is to find dy by dx. So dy by dx, well, e to the minus x squared is a chain. We've got the inside function is minus x squared. So differentiate the inside function, minus 2x, and differentiate the outside function, e to the bracket, differentiates to e to that same bracket. So there's my dy by dx. d2y by dx squared, well, now I have to observe that this is a product. So I've got a u and a v being multiplied together. So u equals minus 2x, v equals e to the minus x squared. So u dash is just minus 2. Now differentiating v, I've just differentiated e to the minus x squared. That was my original y, and it differentiated to this object here. So v dashed, I can just copy that. V dashed is minus 2x e to the minus x squared. So product rule says that differentiating a product, it's u dashed v plus u v dashed. So my u dashed is minus 2 times v is e to the minus x squared plus u, which is minus 2x, times v dashed, which is minus 2x e to the minus x squared. And that's my d2y by dx squared. Now I'm going to want to say this is 0 at an inflection. So I can spot that there is a common factor of e to the minus x squared times a big bracket is going to equal 0. Okay, and for this term I just need a minus 2 in here. And for this term here I've got minus 2x times minus 2x is plus 4x squared. And that's all I've got. I've got an e to the minus x squared. So something times a bracket equals 0. So either e to the minus x squared equals 0, but that's never true. E to any power is never 0. You can try learning 0 and you'll get an error. So that's got no solutions, but there will be solutions to minus 2 plus 4x squared equals 0. That implies that 4x squared equals 2, so x squared equals a half, so x equals plus or minus the square root of a half. Don't forget the plus or minus. So it appears I've got two candidate points of inflection, and to find them as points I need their y coordinates. But before I do that, I should jolly well check that they really are points of inflection. So hopefully the third derivative, d3y by dx cubed, will confirm that. So I need to go back to my d2y by dx squared, which is this. Let's actually tidy that up a little bit. I factorized it here, but that's... Oh, well, I suppose, okay, I'm going to actually do it as a product. So this is my d2y by dx squared, okay. I need to check that this really is still d2y by dx squared. Did I divide by anything? No, I didn't, so I can write d2y by dx squared here. Okay, to make sure I'm differentiating the genuine article, not a random stage in my work. So d3y by dx cubed I can find by treating this as my u and the second bracket as my v. So let's do that here. U equals e to the minus x squared. V equals minus 2 plus 4x squared. So this time it's the u dashed. Yet again we have to differentiate e to the minus x squared, which is the first differentiation we did. The answer is minus 2x e to the minus x squared, just as it was from here to here the first time I did it. And differentiating to get v dashed, minus 2 disappears, so it's just 8x. So d3y by dx cubed is, well, it's still u dashed v plus u v dashed with this new u and v. So u dashed v is going to give me minus 2x e to the minus x squared, brackets minus 2 plus 4x squared. And then plus u, which is e to the minus x squared, times v dash, which is times 8x. And I'm interested in what this is when x is the square root of a half. So, I mean, there is a common factor of e to the minus x squared, which I know will be positive. Can I be bothered? Yeah, I suppose so. Actually, you know what? There's a 2x e to the minus x squared, because I've got 2x here and I've got 8x there. So I've got all of this is just the minus of that, so I need minus 1 times this bracket, so that's 2 minus 4x squared. And then to make this, I need 4 times this 2, so I need plus 4. Okay, and then I substitute in x equals, okay, well, I've got to do both potentially, so x equals root of a half, so I get 2 root a half e to the minus, well, root a half squared is just, that should be an e to the power of minus a half, okay, times 2 minus 4 times x squared is going to be a half, when x is root of a half, plus 4, okay. Well, 2 minus 2 is 0. This is positive. E to any power is positive. This is positive, and this is positive. So this is greater than 0. So it's not equal to 0. Therefore, that was a point of inflection. So when x is the square root of a half, whatever y is, we'll have a point of inflection. And then we do the same thing with x equals minus root a half, but in fact, if you look at where x appears, it's only here where I have a difference. I'm going to get minus 2 root a half times e to the power of x squared is still going to be a half. The minus sign will vanish. So the rest of this expression, actually, the minus a half here, and the 2 minus 4 times a half plus 4, it's all going to be the same. So because of this minus sign here, this will be negative, but once again, that's another point of inflection. So when x is minus root a half, I get a point of inflection. So they're both points of inflection. There is where I've claimed that, and I just need the y coordinates. And again, I've run out of room. But all I'm doing is I'm putting x is the square root of a half, or minus the square root of a half, into this. And whichever x I have, when I square both of these, I'll get a half. So they're both e to the minus a half for the y coordinates. So in each case, the y coordinate will be e to the power of minus a half, e to the power of minus a half. They are both points of inflection. So this bit here, can't really double underline it. I'll put it in a box at the end of my solution. So that should be good enough. Oh, I've circled the box of the noughts as well. Never mind. I'll double underline these bits here, actually. There. Okay, that'll do. Actually, I'll write out point of inflection properly both times and not use lazy ditto marks. Okay, that is clear.